Hi everyone, in this video I'm going to be talking about section 5.4, the sum and difference identities for sine and tangent functions. This is directly related to the sum and difference identities for the cosine function, which I talked about in the previous video 5.3. So I recommend watching the 5.3 sum and difference identities for cosine first. It'll help this video make a lot more sense. Here are our two formulas for sine. Sine of a sum or sine of a difference. The sum of two angles, a plus b, and then their sine value, and then a minus b, and then the sine value of that difference. So sine of the sum involves individually sine a, cosine b, cosine a, and sine b. Notice, and very much the same for sine a minus b. Notice that the two formulas are almost identical other than the plus or minus sign. So if you remember back from our cosine of a sum or difference, this plus or minus alternated, but for sine it doesn't alternate. If you have sine of a plus b, then the formula has a plus sign in it. Very much the same, sine of a minus b, the formula on the right side has a minus in it. Other than that, these two equations are identical. Alright, let me introduce the sum and difference identities for tangent. Again, this is a slide for deriving the identities. You can go ahead and pause it and read through this if you'd like. This is just showing you where the identities come from, and we're going to go into just starting to use them. So let me introduce them to you and show you what they are for tangent. Our tangent of a sum and tangent of a difference formulas. So tangent of a plus b, tangent of a minus b can be broken down on the right side in terms of individually tangent a and tangent b. So notice that the formulas again are both identical to each other than their plus and minus signs. So tangent of a plus b, there's a plus sign on top in the numerator and a minus sign in the denominator. Tangent of a minus b, there's a minus sign on top and then a plus sign in the denominator. Let's try this out. So find the exact value of sine of 75 degrees. Okay, so in the last video, section 5.3, we broke this down how you figure out how to separate this value, in this case 75 degrees. You want to separate it into two different angle values, angles that you know about. So if you think about 75 and how you can possibly get 75 from angles you know about, hopefully you're thinking along the lines of 45 degrees and 30 degrees. So this is something you have to come up with. And you can use your unit circle. It's usually the best option for figuring out how do you break apart this value you were given. And it's either going to be broken apart as the sum or difference of two angles that you know about. In this case, it's the sum. We know sine and cosine of 45 degrees, and we know sine and cosine of 30 degrees. So we're going to use that to our advantage to figure out this exact value. Okay, so just a reminder, our sine of a sum formula that we just learned about, we need sine A times cosine B plus cosine A times sine B. And in this case, A is 45 degrees and B is 30 degrees. Okay, so we fill that in, those values into our formula. And then we know each of these four values, either from your unit circle or if you have a calculator that will give you exact values, not a decimal approximation, but the exact value. So here's our exact values for these four sine and cosine values. And then after we simplify, our final answer, square root 6 plus square root 2 all over 4. Let's try this example. So finding the exact value of tangent 7 pi over 12. Okay, also again, I broke this down in the last video for how you're going to be able to figure out how should you rewrite, in this case, 7 pi over 12. But let me remind you, some angles that we know about in radian measure from our unit circle. You can rewrite them with the denominator you need. We are interested in the denominator of 12. So we know about pi over 6, pi over 4, pi over 3, and pi over 2 from our unit circle. And these are the equivalent radian measures just with a denominator of 12. So think about it real fast. You can pause it if you want. Think about how you're going to get a 7 pi over 12 using a combination of any of these two. Okay, hopefully you came up with adding 3 pi over 12 and 4 pi over 12, which if you go back to their simplified form is pi over 3 and pi over 4. So tangent 7 pi over 12 is exactly the same as tangent pi over 3 plus pi over 4, because when you add those together, it is 7 pi over 4. And now we have tangent of a sum of two angles, and we can use our formula, our identity, tangent of a plus b. Okay, so let's fill this in. So everywhere we have an a in our formula, it's actually our pi over 3. And then everywhere we have a b, it's pi over 4. Okay, so we're just filling in our a and b values. And then we know these numbers either again from our unit circle, or if your calculator does give exact values, not the rounded ones, but the exact value, pi over square root 3 here. And so tangent of pi over 3 is square root 3. Tangent of pi over 4 is 1. And we just fill those in to their corresponding spots. Okay, so this is technically the answer at this point, but we do want to rationalize the denominator. So the next couple steps are just simplifying how the answer looks. And so if you multiply by the conjugate of the denominator, so here's the original denominator, you multiply top and bottom by the conjugate. So you change the sign in the middle here, and then you'll FOIL this out. So you can pause this and work this out if you like. You're going to FOIL both the top out and the bottom of this fraction. After you FOIL and start simplifying, we get 4 plus 2 square root 3 on top and negative 2 on bottom. And then the last step, just divide every term by negative 2. And we get our final answer, negative 2 minus square root 3. New example, find the exact value of sine 40 degrees, cosine 160 degrees, minus cosine 40 degrees times sine 160 degrees. So if you kind of recognize what's going on here, this is the opposite of what we've been doing in the previous two examples. You're starting with what would be the right side of our equation, and you're going back to the left side. Is this a sum or a difference of which function, sine, cosine, or tangent? Okay, so if we identify what we have going on, we have sine of an angle times cosine of a different angle, minus cosine of the first angle, sine of the second angle. And so that formula, if we match it up with the original left side of our formulas, was sine of a minus b. So the difference formula for sine. And so that means we need sine of 40 minus 160. Okay, and then if we just start simplifying, that's sine of negative 120 degrees. Now, quick reminder, sine is an odd function, so if you have sine of negative theta, it's the same as having negative sine of positive theta. So this sine of negative 120 is the same as negative sine of positive 120. And we know that value either from our unit circle or our calculator with exact values, negative root 3 over 2. In this example, we write each function as an expression involving functions of theta only. So what this is asking is that if you have any trig functions, cosine, sine, tangent, you're only going to have thetas as the arguments. There's not going to be like a 30 degrees or a 45 degrees or 180 degrees in your final answer. You're only going to have thetas as far as angles go in your final answer. So let's take a look at the first one. Notice we're working with cosine of a sum. So I refer back to my cosine of a plus b formula, cosine of a sum formula from the previous section, 5.3. And so in this case, a is 30 and b is theta. So I'm just going to fill in my formula with those values. And then I know cosine 30 and sine 30 from my unit circle. So I fill in what that equals. And then if I can, I simplify, and in this case, the only thing we can really do is combine these because they have the same denominator. And so final answer, root 3 cosine theta minus sine theta over 2. So notice we did in fact answer the question. Everywhere there's still a trig function, cosine and sine, the only argument, the only angle is theta. All right, let's try part B. Notice you have tangent of a difference. So we're going to refer back to our tangent of A minus B formula. In this case, A is 45 degrees and B is theta. So we'll fill in A equal to 45 degrees in our formula and B equal to theta. Once we fill in those values, we evaluate the trig functions that we know. We know tangent of 45 degrees is 1. So our final answer here, 1 minus tangent theta on top plus, 1 plus tangent theta on bottom. Now part C, notice we're working with sine of a difference. So we'll refer to our sine of A minus B formula. In this case, A is 180 and B is theta. So we'll fill in those values into our formula. And then once we fill those values in, we know what sine and cosine of 180 equal. So we fill in those values and we get our final answer, sine theta. In this example, we're going to suppose that A and B are angles in standard position, and we're given some information about sine of A and the angle A, and then cosine B and the angle B. Okay, so just a quick reminder, standard position just means that your initial side of your angle is on the x-axis, and then your vertex of your angle is at the origin. Okay, so sine of A, we're told is 4 over 5, and then A is between pi over 2 and pi, cosine B is negative 5 over 13, and B is between pi and 3 pi over 2. Okay, so let's look at what we're asked to find. Find each of the following. Sine of A plus B, so sine of the sum of the two angles. Tangent A plus B, so tangent of the sum. And then the quadrant of A plus B. So what I want you to recognize is that you don't actually know what the angle A is or what the angle B is. We know which quadrants they're actually in, but we don't know what the angles are. And we don't really need to know in order to answer these three questions. So for the first two, A and B, these are going to require that we use our two formulas, sine of a sum and tangent of a sum. The quadrant question, part C, well, notice you're told individually the quadrants. Angle A is in quadrant 2 and angle B is in quadrant 3, but you're asked about if you add these two angles, where does that angle lie? In which quadrant? And so we're actually going to have to use what we get from parts A and B to answer part C. Okay, so notice what you're given. You're only told two things. You know sine of the angle A and you know cosine of the angle B. But in order to answer all the questions that were asked here, A, B, and C, notice what else you need from your formulas. So we still need four other things. We need cosine A, sine B, tangent A, and tangent B, all in order to be able to use these two formulas. So we're going to find those four values. So start by finding cosine A, and we're going to use the Pythagorean identity to do this. We know the sine of A value, we were given that, so we fill that into our Pythagorean identity, and we start simplifying and solving for A, cosine A, excuse me. Okay, so if you square this, and you can pause this and work this out if you'd like before I get there. If you square this, you get 16 over 25, and then you just subtract it from 1 over here. That's where the 9/25 come from. And then you'll take the square root of both sides, and technically you get a plus or minus, and so plus or minus 3/5, but we were told A is in quadrant 2, and cosine is negative in quadrant 2, so we pick the minus version of this answer. Okay, finding sine B, we're going to use our Pythagorean identity again. This time we were told the cosine value for B, it was negative 5/13. So square this value and then subtract it from 1. You end up with sine squared is 144 over 169. Square root both sides. And B was in quadrant 3 and sine is negative in quadrant 3. So we pick the negative of when you take the square root here. Okay, so that's 2 out of the 4 things we needed. 2 out of the 4 trig function values we needed. Let's find the last two. So finding tangent of A, Well, we know sine A and we now know cosine A. And so these two, we just use, this is the simplest way to get this, just use the fact that tangent is sine over cosine. So we just have 4/5 divided by -3/5. So tangent A is -4/3. Very similarly, for tangent B, we know sine of B and cosine of B, so we just divide those values, and we get that tangent B is 12/5. All right, and now we're ready to answer all three parts. Part A was the sine of A plus B. So we know all these values now. We're going to just fill in sine A, cosine B, cosine A, sine B. Okay, so these are our numbers filled in, and then after we simplify a little bit, we end up with 16/65. So part A, sine of A plus B is 16/65. All right, part B, tangent of A plus B. We also have all four of these, actually two. This value repeated top and bottom, and this value tangent B repeated top and bottom. And we're going to fill those numbers in. Tangent of A was -4/3, tangent of B was 12/5, and after we simplify a little bit, we end up with 16/63. So that's our tangent of A plus B value. And then part C said, what quadrant did A plus B, the angle that you get when you add angles A plus B, which quadrant did it lie in? Well, from part A, we know that the sine value was positive. If you look back at sine of A plus B, the answer was positive. Right? So if you recall, sine, think of it as the y value. It's positive in these two quadrants, 1 and 2. We also know from part B that tangent was positive. And tangent is, think y over x. Tangent is positive in quadrants 1 and 2. I'm sorry, excuse me, 1 and 3. And so where this is going to overlap, the only place it could be is in quadrant 1. So the angle A plus B lies in quadrant 1. All right, in our last example here, we're going to verify that this equation is an identity. So basically just prove that this equal sign is valid. So with any identity that you're trying to verify, start with the more complicated side, and hopefully you can tell that the left side has a lot more going on than the right side. So we're going to break apart the left side. All right, so notice the left side had the sum of an angle for sine and the sum of two angles for cosine. So we actually have to use both of our identities back over here for sine of A plus B and cosine of A plus B. Now, in the first quantity, pi over 6 is our A value, so fill that in for A. And then in our second quantity pi over 3 is our A value, so fill that in for A. And so when you break this down, you end up with 4 values that you know. We can figure out with our unit circle or a calculator that gives us our exact values what sine of pi over 6 and cosine of pi over 6, cosine pi over 3, sine of pi over 3 equal. All right, so we fill in those values, and then we start simplifying and combining like terms. So notice what we end up with. We have 1/2 cosine theta plus 1/2 cosine theta, because these two sine values add up to 0. And 1/2 of something plus 1/2 of something, you just get that something. So cosine theta, which was the right side, so we have verified it. And that is the end of this section.